Hi there, my name is Vladimir Gordiev and I want to show you one my demo project that I have published recently. Once I've spent a half a day searching for one obvious bug in my Erlang code, I spent a lot of time because I could not derive what's really happening from logs that I had. And if I had something like Google Maps for events in programs, where instead of streets and buildings I could see processes and messages, it could take minutes instead of hours to resolve problems that programmers typically have, as I did. So this demo is just an attempt to explore an idea, nothing serious. Okay, so let's start the new shell in this web interface that I've made. Okay, so here you see the shell output, text output. Here's the input and the prompt. These rectangles are processes. These are three auxiliary processes that were started by shell. This is the main process. And you can see on the right, it's pit, parent, and here you can see that this process spawned by this parent. In this demo, only shell processes are traced and recorded, so if message is sent to a process that is not spawned by shell and it's not displayed here, then the message is showed as an arrow to some white space. Yeah, but usually it's supposed to show arrow from one process to other. Okay, let's try to make some input. Let's just try to execute this. I can send it by pressing Shift Enter or just clicking Send to Shell. And see, something happens. One auxiliary process dies, the other remains. There's some message between these processes, something related to input-output of the terminal. Then the number is finally printed and we're back to the prompt. Okay. Let's go next. As you may know, you can learn your own PID, process ID, by calling the self function. Let's try to do it now and see what's gonna happen. This is my PID self. Okay, input, output. Okay, you can see that the PID in output is highlighted. You can select it, and the process that is referring to is highlighted in this graph. Yeah. Okay, let's go on, move on. What's gonna happen if we send a message to itself? This is a message. As you can see, there's an arrow that points to the same place it started from, and this is the message that sends to itself. That's it. That's how it looks like. Yeah. And just like in text, people used to read from top to bottom and would think about it as time flows from top to bottom. Here's the similar thing. Processes are flowing from top to bottom. They start in the top, do something, some events happen, then they die. And if the process terminated with reason other than normal, then this process is highlighted with red rectangle on the bottom. Okay, let's move on. Yeah, let's try. We all know that in all programming languages, division by 0 is deadly operation. Let's try to look what's gonna happen if we do it here. So I'm dividing by 0, set it, and we can see that there's an error, and we have terminal output about it. And if we call self again, we may notice that this is the other process. The old one, self, that we executed before, is dead now. It's finished. And the new one was spawned after error. Okay. Let's move on. Actually, we can do something more interesting. I have prepared one module, a join server, that we can try on this shell and see how it behaves. Here's the code. As you can see that here, this option makes this process register on its own module atom after spawn. So this process after spawn is going to be available on Neo atom. And also you can notice that this process is going to die from any message or call except for this, find Smith. Everyone else is going to lead to termination. Okay, let's copy it, paste it here. And this thing detects that this is not just a comment, this is a model code. And instead of executing it, it proposed to store it as Erlang module with this name. So let's do it, store. Oh, yeah, as you can see, it's uploaded. MD hash and MD5 hash. Okay, now we need to compile it. Hash. Yeah. Compile. Yeah, you can see compilation is a complicated process. You can see what messages are sent, what kind of processes are spawned. Yeah, at the end, compilation is successful. Okay, now we can spawn it. Let's spawn a Neo process. Neo start link. Okay, here's the output of terminal selected, and now the process that we just spawned is selected, and it registered as Neo. You see it here. This is the function that was used for spawn. Okay, if we try to check, is it really under this atom? Yeah, this is the process. It's registered on. Okay, any message except for call find Smith should kill this process. Let's try to kill it. Neo. Let's send it something unexpected, like a truck. Okay, what happens? Here's the Neo process, and it dies. Unknown message, truck. If you look at the code, that's exactly what was expected. Unknown message. And dead. Okay, and we start over. Okay. Also, we can go deeper and try to start a supervisor process. Here it is, Morpheus, that will look after Neo and try to restart it every time it dies. Yeah, actually you can upload models also by selecting files. So go here, select it, upload, here it is. Now compile it. successfully compiled. Okay, now let's forget the old pit. Forgot. Now we spawn supervisor process. Morphos start link. Boom. So what's happened? This is the supervisor bit. As we can see, it spawned the process Neo. Neo sends message back to supervisor that acknowledged that it initialized correctly. Okay, and supervisor itself also sent a message of acknowledgement to the shell process. Okay, great. We can check, is the Morphos really alive on this atom? Yeah, same pit is there. Okay, let's try to kill now again by truck. So here our supervisor, here was our Neo. After execution this command, it dies in reason unknown message, truck, and its parent, supervisor, starts Neo again. Okay, again. Where is Neo? Neo is here. Yes, this bit. Okay. We can try to kill it several times online and see how it's gonna behave. And also, in the supervisor code, we specified that if some process is restarted by this supervisor 5 times in 1 second, then it should be considered as failure and the whole supervisor should die. Let's try, is it really work like that? So we need some utility function that's gonna kill Neo by truck several times. Yeah, in case if he's not alive. Truck. And after we send a message that should kill Neo, we should sleep some time, just to be sure that we don't send messages faster than its response. So just send, wait until it get up, send again. Okay. Correctly created function. Now let's try to spawn it several times. Okay, what happens? So here was our Neo, and it dies because of the first message, truck 0. Its parent is supervisor, and it starts Neo again, and this is the shell process, and it sends a message truck, and it dies. Okay, it responds again. Shell sends a message truck, and it dies, and it happens several times until 5th time. Then the Neo finally dies, and Morphos supervisor also dies, and now we don't have anyone. They're dead now, and the shell was restarted because supervisor was linked to it. So that's something expected. And if we try to see, is there anyone there alive? No, it's undefined. It's dead now. Okay, that's it. I hope that you have found this demo interesting. You can find some additional details in the description of this video. Thank you for watching.